Hello, everybody. How's it going? Well, today we're gonna have Bruno from Microsoft that is gonna talk about the Microsoft building of OpenJDK, the use of jlink for creating custom runtimes for Java apps. Okay. I'm sorry that I'm not talking in French, but Bruno doesn't speak French, since I know. L'équipe d'organisation, the team of the organization team, it's Henry, Rohan, Xavier, Anthony, Marion, et David Avena. Our sponsor. What is nos commanditaires? Je ne sais pas comment se dit en anglais. Sponsors en anglais. Ah oui. It's a Banque Nationale, Adaptative in Alicia. And again, we have our guest over here, Bruno. Tu veux parler maintenant, Xavier, sur le...
Yeah, okay. I'm going to announce our next event. It will be live on the 16th of November, and it will be Jonathan L'Hermitage presenting how to do an IntelliJ plugin. So it's going to be interesting. And I have not published it yet, but we will have another event on the 8th of December about Micronaut, and I will tell more later. Back to you, Ron.
Okay, right now we're going to set the Bruno screen, and let's remove that. And can you share your screen, Bruno? The stage is all of yours.
Hi, hello. My name is Bruno Borges, and I work at Microsoft. And je ne parle français, pardon. I only speak Portuguese and English, and it's not even Portuguese; it's Brazilian Portuguese, so it's not a big deal. I work in the Microsoft Java engineering group, and I'm part of the team behind of the Microsoft Build of OpenJDK, a new distribution of OpenJDK for Java developers. And today I'll talk about this and also walk developers through how they can use jlink to create their own Java runtimes, and why this matters and why this is important. So, so to get started, I put together a few slides here just to for guidance, but I want really to answer this question, like why Microsoft has a Java engineering group. The answer is Microsoft uses Java a lot. Not many people realize this, but Microsoft is actually a large company that has several other companies inside of it. Perhaps the most well-known is Mojang, Minecraft. And Minecraft runs two large pieces of Java software. One is the Minecraft Realms, which is a server-side service for running and creating your own servers. Microsoft helps you set up the Minecraft servers. And the other one is, of course, Minecraft Java Edition. We also have a service called Yammer that is heavily implemented in Java in the backend. We also have the search engine Bing, and and Bing uses Java mostly for its search index with Java technologies, Java-based technologies. So there's considerable amount of data behind the scenes at Bing for that. Perhaps one that is also known as a Java backend is LinkedIn. So all of the LinkedIn systems for managing your network, managing messages, and managing events for your timeline at LinkedIn, these are all systems implemented in Java with microservices. And finally, there's also a lot of Java for maintaining the infrastructure of Azure. Of course, developers can run Java on Azure, but here we are talking about pillars of the Azure infrastructure that are implemented in Java to help orchestrate the Azure cloud itself. So one example is we use PubSub implementation, Java-based implementation of PubSub for sending messages from the dashboard where you go, portal.azure.com, when you want to create a new VM or you want to create or deploy a new application. Everything that you do through the portal or through the command line will ultimately become an event in the PubSub. And once that event is there, it will be hosted in a Java-based piece of infrastructure. And then another component will take that event and execute on that command. So for example, I want to create a new VM. This goes to the central server of the dashboard of the control plane of Azure. And then that says, hey, create a new VM in data center X. So data center X will have an agent monitoring the PubSub. Oh, okay, I got a message. I have to create a new VM. All right. That is all implemented in Java. So when we combine all of these use of Java inside Microsoft for its own business needs, we have an estimate of at least 500,000 JVMs in production. We do believe that that number is a lot higher than what we are estimating, but it's already safe based on the metrics and analysis that we've done so far in production. These are the JVMs that we were 100% capable of identifying that are always there running. So it's not a big environment considering some of the top 10 Java customers in the world, but given Microsoft's DNA is not necessarily in Java, in the Java ecosystem, it's a very big environment of Java virtual machines inside Microsoft. So that's why we find it important. And if Microsoft depends on Java to run its businesses, of course, Microsoft wants Java to succeed. And by wanting Java to succeed, we also want Java to succeed for our customers. So the external workloads, the third-party workloads that run on Azure, we also care very much for them. So that's why the Java engineering group was formed. A group of people that will look and really care for the Java workloads inside and outside Microsoft and help improve the platform for many years to come so that we don't have to make significant changes and our customers don't have to make significant changes. And all of the performance enhancements, all of the improvements that can happen with Java, not only our customers, but ourselves can benefit from those. That's why our team got formed. That's why we contribute to OpenJDK. So I mentioned before, like Minecraft Java Edition, outside our infrastructure, outside our data center, Minecraft actually has millions of gamers running the Minecraft Java Edition with the Microsoft Build of OpenJDK already. So a couple months ago, I think it was July, Minecraft updated to Java 16. they were on Java 8, and they updated to Java 16. So they doubled the version from 8 to 16 in that version. And now the team is looking at 17, given that 17 is now the latest LTS, long-term support release of Java. This should happen in the next following months. So I guess it's now safe to say, hopefully, that Java 16 is the most widely deployed version of Java in the world because of Minecraft, and that's how we optimistically look into this. So what is the Microsoft Build of OpenJDK? Well, it is a distribution of the OpenJDK project, and some people may ask, is this a fork? And the answer is no. OpenJDK is the source code of the reference implementation of the Java virtual machine specification and the Java language specification. It is the source code that shows how to have the Java platform in the first place, and also the Java APIs. So when people ask, oh, I'm using OpenJDK, well, you actually have to think a little bit more and come to realize that you are using someone's OpenJDK or someone else's OpenJDK. And the reason for that is that OpenJDK is just the source code, does not come with binaries. For OpenJDK to have binaries, somebody needs to get the source code and build binaries for somebody else or for themselves. Historically, Sun Microsystems and Oracle were one of the few producing binaries of OpenJDK until other vendors and other entities decided, well, I can also build a binary of OpenJDK. So one classic example that many developers don't realize is that when you are on a Ubuntu server or Debian server, and you do apt get install OpenJDK, you are actually downloading a binary that was built, compiled, and hopefully tested by the Debian community for the Debian distribution of Linux, or by Canonical as part of the Ubuntu packages. So you're always running someone else's OpenJDK. You're not running the OpenJDK project. And there are many reasons why you would prefer these persons or these entities OpenJDK versus this other. Sometimes it's just convenience, as for example, Ubuntu. If you are on an Ubuntu server and you do apt get install, you will get Canonical's build of OpenJDK. But sometimes you do have more control, and sometimes you want to be more specific about who you're getting the OpenJDK binary from. Oracle is a great vendor of Java. I mean, they are the steward of Java. Most of the contributions to OpenJDK are done by Oracle. Most of the maintenance of OpenJDK are done by Oracle. So it's not surprising that Oracle Java is one of the largest distributions of Java being used out there. But you may want a different vendor. You may say, I've never done business with Oracle before. I think I'm going to go with someone else. That's fair. That's what open source is about. It's about competition. It's about having choice, and it's about you feeling the most comfortable with whoever will give you support best. So there are other vendors in the market like Azul Systems, Bellsoft, Amazon Creator is another distribution of OpenJDK. Red Hat and IBM, but they both offer their own Java distributions. In the case of Red Hat, they produce the build of OpenJDK for Red Hat. They also have binaries for other operating systems. And IBM has their own implementation of the Java platform based on OpenJ9 virtual machine. So there are different options out there. Even Alibaba has their own. They have their own OpenJDK distribution called Dragonwell, and that distribution is still based on the OpenJDK project. And finally, back to Oracle, where they offer the traditional commercial distribution of Java, Oracle Java, but also the free GPL-based version called Oracle OpenJDK, which does provide some guarantees of support for a few quarters. And then customers who want to continue, they either have to migrate to the latest version of Java or to the commercial support. But either way, what matters is that there are several options. There are several reasons to choose one instead of the other. The Microsoft Build of OpenJDK is one of these main distributions. It is based on the same source code, the OpenJDK project, but there might be a few differences with other distributions of OpenJDK. All of them will be compliant with the Java specification, but sometimes you might see differences in for example, which patches are applied to a certain version, a certain binary. And that's mostly what are the differences between these different distributions. Even though they all come from the same source code, sometimes, especially with older versions of Java, the version may not have all of the changes that have happened upstream that are backported to older versions. One example, the Microsoft Build of OpenJDK has an enhancement on MD5 processing. So the MD5 checksum happens slightly faster with the Microsoft Build of OpenJDK due to a patch that we developed, and we did open source. It's on the OpenJDK project already for latest versions. So if you are using OpenJDK 17, if you are using the distribution of OpenJDK 17, you already have access to that flag for faster MD5 intrinsics. But not on every OpenJDK 11 distribution out there, because the patch is still waiting to be backported by the OpenJDK 11 open source code. And the maintainers of that source code have other priorities. That's perhaps why this particular patch has not been merged yet. But the OpenJDK binary for Java 11 of the Microsoft Build of OpenJDK does contain this patch. So what are the other differences? Well, we use the Eclipse Adoption project to build and test the Microsoft Build of OpenJDK. Adoptium was used to called Adopt OpenJDK, and now it's the Eclipse Adoption project. Microsoft is one of the primary contributors to this project. We have members of the Java engineering group are part of the steering committee of the Adoptium project. So sometimes our engineering group will find some problems that are impacting the Microsoft Build of OpenJDK in those build scripts and tests, but we will patch those first in the Eclipse Adoptium project. And then later on, we bring those changes to our own infrastructure for building OpenJDK that uses the same scripts. So that's what OpenJDK is about. That's why you have different distributions of OpenJDK. And that's why Eclipse adoption is so important, because it's not only provides build scripts and tests for anybody to validate their OpenJDK distributions, but it also allows a more vendor-neutral distribution of OpenJDK to exist, where different companies and different individuals collaborate with each other through the Eclipse Foundation to produce binaries of OpenJDK that are tested and certified against the Java specification. So if you do want to know more about, if you have questions, please feel free to reach out. I'll be very happy to answer those. So this is just like a short overview of everything that I've said before. But the other interesting thing that Microsoft did was to contribute with OpenJDK months ago with the port of the OpenJDK project for Windows on ARM, and also the port for macOS M1, which is also an ARM-like ARC64 architecture chip. The Windows port Microsoft implemented from scratch. We wrote code that actually allowed OpenJDK to be compiled under running on Windows on an ARM chipset. And the interesting thing is that some of that code was actually an enabler for the macOS port for ARC64 for M1. So we contributed directly to the macOS port as well, despite, of course, Microsoft being a well-known Windows company. We did contribute, and the reason we felt it was so important to contribute to the macOS M1 port is because, as I said, Microsoft deploys Java inside our infrastructure. That means that we have Java developers. We have lots of Java developers, and many of them are using Apple devices. So we have to guarantee that our own developers will be able to continue developing in Java even when they move to a different hardware. From a MacBook Pro running on Intel to a MacBook Pro running on M1. And that is happening. That is happening. Some Java developers have completely migrated to the M1 series, and they are using the Microsoft Build of OpenJDK because we produce a binary for macOS ARC64 as well. So this is a table of all the versions and architectures that we support. So basically, we support 11, 16, and 17. 16, we make binaries available. Support is an overloaded word. I'll talk more later. But we make binaries available for 11, 16, and 17. 11 and 17 are LTS, so we will continue to provide updates to these binaries until for the next coming years. We have a documentation in our site that shows the final dates, always subject to change. But what you can see here is that the only architecture not available is Apple M1 for Java 11, which requires a backport of those changes in the OpenJDK project from 16, where this got implemented, and a few enhancements in 17. Those changes need to be backported to the branch that maintains the OpenJDK 11 code. Until those changes are merged, we are not able to produce. We could, but we're not interested in producing a binary for Apple M1 right now for OpenJDK 11 until we have those backports validated, tested, and confirmed also by other OpenJDK contributors. So we are working on this. We may publish binaries even before the merge happens, but we are working hard to get the merge to happen before that. So we avoid too much of a discrepancy between the code that we maintain and the actual OpenJDK source code, because those patches, they have to be maintained somehow. And that's why we try to avoid that. The other thing that we do produce is Docker images. Of course, many developers deploy Java applications to containers. They They deploy applications to Kubernetes, and of course, they need Docker images. We produce only 3 base images. One is based on Ubuntu, the latest LTS release of Ubuntu. And the other 2 are Microsoft Linux distributions. These Microsoft Linux distributions are maintained in the open, and the first one, KubeOD, is Debian-like, and the second one is CentOS-like. I just separate them based on the packaging system that they use, either Debian package with apt-get or RPM packages with yum. We do not provide support for Windows containers. We've asked for feedback, and we have not gotten any customer running Java on Windows containers in production. But if you are one of those, please reach out, and we can evaluate adding Windows containers. And these images will be used in the remainder of this presentation for when we talk about jlink. And this is what I mentioned before about MD5, the patch that we have in Microsoft Build of OpenJDK for version 11. This capability is only available for OpenJDK 11. It's only available on the Microsoft Build of OpenJDK because the patch is still waiting to be merged, to be backported into OpenJDK 11 upstream source code. But it's already available in OpenJDK 16 and 17. 17 for sure, 16 not 100%, but probably. So if you want to take a look at the documentation, we maintain it under docs.microsoft.com/java. Just recently, we added translations for several languages, French included. We added translations for Japanese, Korean, Mandarin, and Taiwanese Chinese. We added translations for German, for Russian, Brazilian Portuguese, and Spanish, and a couple other languages that I might be missing. But French is certainly there. The other thing that people ask is, well, where's Java 8? Where's Java 8 for Microsoft Build of OpenJDK? So Microsoft Build of OpenJDK does not have a Java 8 version because we feel that that would only perpetuate the existence of Java 8, and we really want developers to move to the latest and greatest. There's several reasons why you want to move to a Java 11 version or even a Java 17 version. But we do understand some developers may not just be able to for different reasons, sometimes technical reasons, sometimes even non-technical reasons. And for that reason, we do support Java 8 inside Azure through the OpenJDK binaries from the Eclipse Adoption project. As I said, Microsoft contributes to this project. Our engineers work on adopting themselves. So it only felt the right thing to do in certifying or ensuring that we support those binaries when they run on Azure. And those are the distributions. Those are the binaries that we use, the Eclipse Adoption distribution. The binary is actually called Eclipse Xamarin under the Adoption project. You may not see it. It took me a while. Somebody had to tell me, but Xamarin is actually an anagram for runtime. So there you go. That's the Easter egg for this slide. Xamarin is an anagram for runtime, and I would have never realized that because Xamarin is such a weird name that doesn't make me think about anagrams whatsoever. So I mentioned before on table how you can install the Microsoft Build of OpenJDK. The reality is it's pretty much the same as almost every OpenJDK distribution out there. We have compressed files where you can just unzip the content and you have the JDK to go. If you want to uninstall, just delete the folder. Pretty simple. And if you want to update JDK, just replace the content or extract the file to a different folder and change your Java home environment variable. It's as simple as that. But some developers actually prefer to use package managers and installers. So we leverage the Adoption project for that. They have scripts for generating installers, and we use those to also produce the installers for Microsoft Build of OpenJDK. So here for Windows, we use MSI, and you can actually install using Wingat, which is a brand new, for the past 6 months at least, package manager for Windows by Microsoft. So you can go to your command line on the Windows terminal and type Wingat search, assuming you have Wingat installed. You can do Wingat search, OpenJDK, and you're going to see all the options, and then you finish by installing the actual package that you want. Behind the scenes, this will use MSI. It will install the MSI package in silent mode, non-interactive mode. So it's just a convenience. And if you want to update, you can use Wingat. If you want to uninstall, again, you can use Wingat, or you can go to your application settings, uninstall applications. For macOS, we also have an installer. We publish as a PKG format, and it's very similar to the Windows one. And for Linux, we have Debian and RPM packages. So Debian for Debian and Ubuntu and other distributions that use this package format. And RPM for CentOS, Red Hat Enterprise Linux, and others. The only thing to consider here is that if you're using these packages, the configuration is done by the OS. You have to manage that, of course. So, for example, in most of the Debian Linux distributions, you're going to use a command called update Java alternatives, and that will give you a list of options of which distribution you want to set as your main distribution. And you can also, of course, use manually define your Java home environment variable in your resource center for your preferred shell. Okay, so let's talk about jlink. So far, so good. Microsoft Build of OpenJDK is just a drop-in replacement to any OpenJDK out there. We provide support on Azure. So if you're running a Java application on Azure and using our JDK, you get free support for that. You don't have to go look into different vendors. It's part of your Azure subscription. You can, of course, do that, especially when you deploy your application and you choose the JDK in what we call the non-managed Azure services. So Azure services where we don't manage the JDK for the customer, that's where you have to choose, you have to manually, actively go and look into an OpenJDK and configure that for your deployment. For those services, for example, AKS or Azure VMs, Azure Kubernetes Services, Azure VMs, and other compute services where the control of which JDK will be used is entirely yours, that's where you have that choice. But some services and some features in some services, we manage the JDK on behalf of the customer. So for those, we will use Microsoft Build of OpenJDK for Java 11 and later, and we'll use Eclipse Xamarin from the Eclipse Adoption project for Java 8. But rest assured, support is provided as part of the Azure subscription. And those binaries are always free, and if you want to deploy them somewhere else, just please go ahead. They are all GPL based and open source anyways. Okay, so let's talk about jlink. So first of all, let's pause here for a second and remind ourselves what is a JRE. Well, the extension, of course, is Java Runtime Environment. I have a Java application in my computer. I need to run this application. I need to install a Java Runtime Environment. That's what we have been taught for many years. The reality, though, is that JREs were produced to make Java available in an end-user computer as a general-purpose runtime environment for running Java applications that somebody would download from the internet on their desktop, and to support plugins in the browser, such as Java applets. But none of those things are common these days. We are not downloading jar files every day of Java applications. There's no such thing as a Java App Store. And quite frankly, even despite being such a great platform for desktop applications, the level of adoption of Java for desktop applications is not as high as we would have hoped for as Java developers. So the need for JREs got reduced significantly. First of all, Java applets are no longer supported in any browser. And that is why the OpenJDK project and Oracle have decided to remove support of Java applets entirely from the Java platform. Applets were a source of security threats. They were a source of bugs. They were a source of incompatibilities. They would break browsers sometimes. So they are not recommended anymore, and for many years already, to be used. Last time I wrote an applet was in 2002. So if there's no more need for a JRE with that sense, with that intent, why would we still need a JRE? Well, some developers do prefer a Java runtime so that they can easily install on servers to run Java applications that they themselves are managing on that server. But that's really just a convenience for that developer. It's not necessarily a requirement or a need. So if the actual needs for JREs are no longer existent, and developers do have full control of the server where they are deploying to, or the Docker image that they are deploying to, and JREs today are just more like a convenience, is it really a need? And I particularly believe it's not. It's just a convenience. So when Java 9 came, Java 9 introduced something called the Java module, the Java Platform Module System, JPMS. Along with JPMS, the module system, it also came the jlink tool, which allows developers to but to make a copy of the OpenJDK that they have without certain pieces of it. So when you jlink your JDK distribution, it will create a copy of it, but filtering out a few elements. So you can select, for example, no header files or no mun pages, or you want to strip debug symbols. So this will create a copy of the JDK without these things, and also without the JDK tools, the development tools like the Java-C compiler or the jar tool. It will only contain the Java command line, which is the JVM launcher, and the modules that you choose as part of the module system, which modules are required for your application to run. In this example here, we do only java.base. Now, this presentation is not about the module system. Please go take a look in great material out there on the internet about the module system. You're going to learn a lot. But the bottom line is applications, Java applications, especially in the server side, they hardly require everything that the Java platform has to offer. So just go and create a Java runtime specifically designed for the needs of your application. This will give you a much smaller environment runtime and more secure, which ironically are the two main reasons why developers prefer a JRE over a JDK. It is smaller for download and is theoretically more secure because it doesn't contain the Java compiler. So if somebody hacks into the system, they cannot just go and generate Java code to inject that Java code into production applications. So there is this sense of more security. Well, wouldn't it be even more secure when you strip down some of the modules of the Java platform so that hacker cannot even load a class because it simply does not exist in the environment? Not to mention the size of the runtime, as we can see from this table here, the size can get down to 20% of the regional size of the JDK, or actually 11%. So there are some benefits for jlinking, and most often than not, the arguments in favor of JREs, they are mostly just for convenience, and that's fair. And that's why some distributions of OpenJDK continue to produce JREs. But there's also another element of the behavior of developers always updating and upgrading to the latest version of Java. Some companies, some teams have set policies over the years where to update Java is such a hassle, such a problem. And the reason for that is because very often Java is being installed as a JRE in a server to support all applications that are running on that environment. And then, of course, it's difficult to just go and say, let's just update Java to the latest version. Well, that's complicated because all my applications are running on this environment with this version of Java. If I upgrade, how do I know if application Z may not break? So that's why, especially when we talk about containers, it's such important to have out the JDK and the Java runtime being shipped with the application. And this can be done even outside Docker images. So the moment that developers start adopting jlink, a couple of things happen. They start thinking more about the Java runtime as a dependency of the project, just as much as the dependencies declared on the POM file or on the build.gradle file, dependencies of libraries. How often does it happen that you don't update a library in a project because it may impact other projects? Well, there are examples where this could happen, but the reality is, if you're working in Project X and Project X has a dependency of a library, most often than not, you will be able to update to the latest version of that library, or at least to a minor update of that version, without impacting other projects across the company, because that dependency is set only for that project. So when we use jlink, when we start creating Java runtimes for each application, we start having this mentality that the Java runtime is a dependency for that particular project, just as much as are the dependencies on your dependency tree of your Maven project or a Gradle project. So this allows developers to more quickly upgrade to the latest versions of Java for individual projects without having to rely on a general purpose company-wide version of Java installed across servers and defined as the default base image for Docker images. This allows developers to move faster, upgrade, and benefit from newer features in Java and performance enhancements, which, by the way, will allow the company to save money. If the systems are running with the latest versions of Java and they cost less to run, the company saves money. So those are some of the reasons for running, creating your own Java runtime. So the Java module system is quite small, big but small, but big, but small. The reality is there are several modules that you don't need in most of your applications, especially when you are dealing with microservices and breaking down your application into several pieces. You may not need all of these modules. I'll give you an example. Java.transaction.exe is something you might not need depending on how you're connecting to databases or even other resources. In fact, there are projects out there for reactive programming to reactively connect to databases. There is one called R2DBC. It's not even based on JDBC. It's a completely different library with different set of APIs. So you may not need this module. You may not need java.xml because you may be doing JSON or YAML or TOML or whatever other format, and you're not actually processing XML anymore in your application. So why have this module? You may not even connect to relational databases, so you won't need java.sql. You won't need Java SQL role set. So these are some of the modules that your application may not require to operate properly, to operate correctly. So remove those. That's what you do with jlink. There are a few gotchas though. And one that we've found was the most interesting one so far is that if you run, there's another tool in the JDK called JDEPs. JDEPs will show you which modules of the Java platform are required by your application. So let's say your application is this big, fat Uber jar that contains all the classes and dependencies of your application, everything in a single jar. You can point JDEPs to this jar and say, hey, analyze this jar. I want to know which modules of the Java platform my application actually needs. Well, the JDEPs tool will look into that and realize, well, you only need java.base. And then you go to production with only the Java base module. But your application actually responds to HTTP requests over SSL, security connection with TLS. Well, for that to work, you need some crypto algorithms available in your Java runtime. And to have those, you actually have to include the jdk.crypto.ec, which is a separate module of the OpenJDK project, not necessarily the Java platform, but of the OpenJDK project that provides a default implementation for the Java, the JCA API, which responds to secure connections, which does the secure algorithm of secure connections. And this module is an example of something that JDEPs will never find. I don't think it's even designed to find, so I don't even think it's considered a bug. But it's something that you have to add in your Java runtime. But most likely what you will get is an error that says module missing, and it will tell you which module is missing at runtime. in case JDAPS is not able to help you very much and you have to come up with the list of modules by analyzing the code and the dependencies. Some libraries will load things over reflection, and that's a dynamic load, and then JDAPS will not be able to identify that. So you might get this error only at runtime when you're actually running the application. But you will get an error message that is hopefully clear. Module X is missing. Okay, so what are the differences? How much of a difference in size are we talking about when we talk about Java runtimes? So last night I worked on this new sample for producing Java Docker images for a Hello World application for microservice. And I did it for Java 11 and for Java 17. And I started with JDK 17. So you can see here, JDK 17 is 454 megabytes. That's the size of the Docker image with Ubuntu, based on Ubuntu. You're gonna see that the reason that JDK 11 is slightly smaller. It's the same base image, it's the same Ubuntu base image, but it's JDK 11. Why is 11 smaller than 17? Well, there is a difference. Starting with Java 12, OpenJDK has a feature called default archive for class data sharing. So when you build OpenJDK with the proper flags and etc., you will have a binary of OpenJDK that includes a file that is a binary representation of all the Java classes in the Java API, the Java platform, that is written in a way for easy mapping with the memory of the environment where you're going to run. So this archive is actually platform dependent for each binary, for each target OS that you're going to write. This file will help OpenJDK start faster. Because when OpenJDK starts, when the JVM starts, the JVM has to read those .class files. It has to extract jar files and then read those .class files and read those structures and put them in memory in an area called multi-space. This takes time. Not only you have the JVM has to open a file, there's IO access to the jar files, and then extract the contents, and then read the contents, then process the contents, then put those structures in memory. So the class data sharing allows the JVM to more quickly have access to the data structures of the classes of the Java API in memory. So that's why Java 17 is slightly bigger than Java 11, because Java 11 does not come with a default CDS or archive, but Java 17 does. Now, we think, well, I cannot deploy 400 megabytes. It doesn't make sense for me to deploy 400 megabytes to full JDK in production. Besides, it's too big and it's considered like insecure or not needed because it comes with several components that I don't need in production, and who knows what could happen if somebody accesses this thing and leverages those components. Well, back to convenience, developers will choose a GRE. Right now, 11 is still produced with a GRE from most vendors, including the Eclipse Adopting project. So this image here is using the GRE from Eclipse Adopting, and it's 246 megabytes. Still big. And this is using Ubuntu as well. Well, there is an image that you can, there's a technique in Docker where you can have a build stage, a multi-stage Docker file, where you have a build stage. And then below, you can have the actual image definition that you will use in production. So the JRE Slim image uses such technique. It is basically 11 JRE. I'm sorry, 11 JDK, but then it installs the JRE with Debian base OS, a variant called Debian Slim. So we are saving around about 47 megabytes just by going from Debian to, I'm sorry, from Ubuntu to Debian. And you may think 200 megabytes is still too big. I don't think particularly it is that big, but sure. Well, that's where jlink starts. You can cut in half if you produce jlink runtime. In this particular application, we were able to cut in pretty much in half because the application is small and doesn't need too many modules. In fact, only needs 2 modules of the Java platform. So with 17 and 11 both, we were able to go down to 107 megabytes. And you can see the interesting thing here is that in 17, we do have the class data sharing archive. In 11, we do not. So 17 is actually more optimized than 11. For the same size, you get better performance. And then there's the ultimate level, which is changing to a Linux distribution that is super small, and that is Alpine. Alpine Linux is a distribution that is not glibc standard. It uses a new implementation of the libc standard called Muzzle. So it requires a JDK compiled for Muzzle. And JDKs that support Muzzle are 16 and up. But some vendors of OpenJDK do have support for Muzzle in older versions of Java, especially Azul Systems and Bellsoft are 2 vendors of OpenJDK that did port the Alpine support of OpenJDK 16 down to OpenJDK 11. And Microsoft, now in partnership with Bellsoft, and Azul will most likely contribute as well, we are working to backport to the OpenJDK source project the support of Alpine down to 11 and even possibly 8. So all the source code is in this project, and I'm gonna get off of the presentation mode and show you the source code so we can understand what's going on. But this is a glimpse of what happens in the Docker file. So it's a multi-stage Docker file. And what we do here is we use JDK to build the project and to create a jlink runtime. So I use jlink and I add only the modules that I need. And then later on, I define the image that I actually need, which is Debian Buster Slim. And I copy the Java runtime from the JDK layer into the Debian Slim layer. I also copy my jar file, and then I just define my command. So when the Docker image, when the Docker container starts, this is the command that will get executed. So let's take a look at the source code of all of this and also do a few comparisons. So first of all, let's look at the basic Docker file. The basic Docker file is this. From JDK, I copy the jar file and I run it. So let's do a Docker run -ti demo app JDK 11 JDK. So we have the application running. I'm just gonna restart the application with a port so we can access it. Now I can come here to my HTTP call and execute. So let's do it again. There you go. Okay, so my application works and my base Docker image works, JDK 17, JDK 11. Well, I can also do 17 because I already built these images. So also works with 17. Okay, so let's go to the next level. Let's produce the JRE image. So here's a Docker file for the JRE. From Eclipse Xamarin, version X, JRE Focal, which is Ubuntu, the Focal variant of Ubuntu. I'm going to copy the jar from my Maven project into the Docker image, and I'm going to run it. So for this application, it's the same code. The only difference is that this is a JRE. And now keep in mind, Eclipse Xamarin does not produce JREs anymore for 17, for Java 17. I think they stopped producing JREs on 16. So let's use 11. Here's my application, same application, but running with a JRE. Okay, so the JRE works fine, but it's based on Ubuntu, and Ubuntu is a little bit heavy compared to other Linux distributions, especially Debian Slim. How can we use the Eclipse Xamarin JRE but not use Ubuntu? I mean, there are several ways that you can do that. You can go to the Eclipse website and download the binary, or read the instructions on how to install the Debian package of Adoptune. But honestly, you are already on Docker. So why not just leverage the Docker capabilities for doing that? So this is how you reuse files that are inside a Docker image as part of another Docker image. You copy them from a different image. So here I have a from Eclipse Xamarin JRE Focal, and I give just an alias to this image. And then I say, actually, you know what? I'm going to use Buster Slim because I do not want to use Ubuntu. I want to use Debian. Fine. But you need to copy the JDK. Well, I do know that the JRE in this image of Eclipse Xamarin is available in the OPT Java OpenJDK directory. So I'm going to copy this path from this image, which is this one here, into the folder Java runtime. And now what I have is a Debian image. There's nothing to do with Ubuntu, but it's a Debian image with the JRE that I copied from the JRE/Ubuntu image that is already available in my system. Well, when I run this thing, I got the JRE Slim, and it's the same application, same runtime, Java runtime, but it just happens to run on Debian. All right, so the next level is do not use the JRE that is general purpose and it comes with all of the APIs of the Java platform. Let's use jlink. We will use a similar approach with multi-stage builds in Docker. So here we have a build stage build, and we're going to go back to Microsoft Build of OpenJDK. We're going to use JDK by default 11. I can also inform 17 here. And we're going to use the base image for Ubuntu. But again, Ubuntu is big. I want to use a different one. Well, we're going to combine jlink with the different base OS. We're going to use Debian here as for the ultimate image. But the JDK does not have a JRE. It only has a JDK itself. So we have to produce the Java runtime. So for that, what we do is we call jlink, and we provide the modules that we need. Now, because I do want a little bit of metrics when I start the server, Jetty. You see that Jetty says it took 349 milliseconds to start. The reason for Jetty to provide this information, it needs java.management module. But if I don't want to see this value, I can just remove this, and this value will be a -1 as like it could not compute the stored time because there's no access to the metrics of the JVM, no API to access the metrics of the JVM. But fine, I'll keep this module just for the sake of this example. In fact, I would say for the sake of any production environment, you probably want this module, so you have good metrics for monitoring. Anyways, so I'm going to add these modules. I'm going to strip debug information from Java classes and everything else. I do not need them on pages. I do not need header files. I want to compress to the maximum, level 2. And I want my output to be on the /Java runtime folder. Okay, great. So the Java runtime gets created. And now all I need to do is similar with what I did before. I have a base image, Debian. I copy from the stage build the Java runtime into the Java runtime folder. And then I do set the Java runtime /bin as part of my path environment variable. So I can just do a Java -jar in the command instruction here. So problem solved. Now I have a jlink runtime Docker image that has a different base OS than the one of where I'm getting the JDK from. And I don't need to do apt get install or wget or anything like that, which pollutes my Docker file. I have to be careful of not keeping those binaries in the Docker image and so on and so forth. This is a much better, much cleaner way of doing the Docker image. So let's run this thing. 11 jlink. So same image, same behavior as before. The application works fine. And all I needed was a few tricks on the Docker file. What about Alpine? So Alpine is even smaller than Debian Slim, but it's muzzle libc implementation, not glibc implementation. So for that reason, you do need a muzzle compiled JDK. As I mentioned, Bellsoft and Azul systems do provide muzzle binaries of OpenJDK. So here I'm using the Zulu OpenJDK for Alpine, which is a muzzle binary. And I'm grabbing the version 11 as my stage build. And I will do a jlink for this, even on Alpine, doesn't matter. And then as my base image, I'm gonna do Alpine. Now, this is important. Again, if you want to run JDK on Alpine, it is highly recommended that you use a muzzle binary of OpenJDK. So that's why in here, I cannot use the Ubuntu variant of Zulu, because the Ubuntu variant of Zulu will give me a JDK that was compiled with glibc instead of muzzle, and then it won't work on Alpine. Well, there are hacks that you can do make it work, but I don't recommend that. Okay, so I have a stage build with the JDK for muzzle. I build my runtime. I copy that into my target image, which is also Alpine, and then I copy my jar file from my local Maven project into that folder, into that image. And then now I can just run this with Alpine. Application is running, and everything still works as expected. All right. So here we saw how we go from JDK, full JDK, to the smallest bit using Alpine with jlink. What about the Docker image sizes? And what about other images that are available out there? Google has an interesting project called distroless images for Java. Well, there are great developers at Google. The folks at Google have done amazing jobs, like the Jib project is super awesome, the Maven plugin. But I do not like the word distroless here. And the reason I don't like the word distroless, it's because it makes you think that there is no distro behind the scenes of those images. Well, I'll start explaining that by showing you the image size of the distroless images. So here we have all of the images that I've been showing you so far. You can see that the demo app images are as I described in the chart of the presentation, from 459 megabytes down to 42.9 megabytes with Alpine on JDK 11. Again, the difference between 42.9 megabytes to 44 megabytes is CDS. Java 11 does not come with CDS by default. You do have an option to generate that, and I recommend that you do if you're on Java 11. And to do that, all you have to do is go to your Docker file and put at the end run java -x share dump. So if you do this on your Docker files for Java 11, you will create a CDS archive, which will make your Docker image stored faster with Java 11. Some Docker images out there are already doing this for OpenJDK, but it's okay if you have this on your Docker file as well, because it will just either update the file or not do anything. So there's no error here calling this again. All right. So let's look into the distroless image, as I was saying. So distroless is super convenient for several developers. But if developers care about the size of the image, is it really the best solution? Well, we can see that the JRE11 from Eclipse Xamarin is 244 megabytes. But if we produce a JRE Slim with the Debian Slim variant, we actually get down to 199 megabytes, so 45 megabytes smaller. If we use the distroless version of Java 11, either Debian 10 or Debian 11, we still get something bigger. So the main difference here, though, is that this includes the JDK, and and that's important to keep in mind. So how can we get smaller? Well, for distroless, I think it's not that simple to produce a custom distroless image. The source code is available. You can go and look by yourself, but I don't think it's that simple to tweak as I did here with all these Docker files. So your only way is basically to use as is. You're going to use this image as is. And that's okay, because 206 megabytes sounds reasonable. But if you can go to 100 megabytes, half the size, without relying on Alpine, which is a muzzle, it's a different operating system and different libc implementation, why go in distroless? I mean, sure, jlink may add some inconvenience at the beginning, but once you have this code automated, is it really that a convenience? And besides, it makes so much easier for you to upgrade to the latest version of Java without having to wait for the distroless project to produce a new version. You have more control of your Docker images if you do these yourself. So distroless goes from 206 to 107 megabytes with jlink. And is it really distroless? So one thing that we can look into is the source code of the distroless image. I like to say distroless image is lacking a distro as much as serverless is lacking servers. Of course, there are servers behind the scenes in a serverless platform. And in here, of course, there is a distribution of Linux being chosen by default for you to allow you to have this image. So how do we look at that code? We look at build, and we realize that this image is produced out of Debian. Of course, we saw that because it's in the tag. But what about the JDK? Where is the JDK coming from? Who produced the binary of OpenJDK that is distributed as part of the distroless image? Well, it's the Debian binary. And we can look that by looking at the package that is installed. Is the OpenJDK, whatever version, 11, 16, 17, JRE headless. That is the package, the Debian package that is being installed on the distroless image is the Debian binary of OpenJDK. So is it really distroless? It's not distroless. It's based on a distro. You're deliberately choosing a JDK from Debian. And there's a catch. The OpenJDK project compiled by the Debian community is the same source code. It's available. It's based on the same source code as all the other OpenJDK distributions that I've mentioned, but it's not certified against the TCK or the JCK, the Java compatibility kit of the Java specifications. So for now, of course, everything works, and I doubt there will ever be a problem. But if your company cares about certifications and some sort of like a compliance or some of like non-technical requirements, you may actually prefer to go with a distribution of OpenJDK that has all these guarantees as part of the distribution. And Debian, even though great, does not, unfortunately, cannot provide those guarantees because it's a community-driven project. It's a community-driven effort, and does not provide those certifications and guarantees. So distroless is a great project, but there are better alternatives out there that will give you every check mark for your Java needs. Okay, so what are we looking into then for the future? So as of the next step, here's like an idea, a glimpse of the roadmap for the Microsoft Build of OpenJDK. So now we are in October, and we are this week, if everything goes well, we will have the PSU, the pad set update, or the update, the quarterly update for Java 11 and 17 of the Microsoft Build of OpenJDK. By the end of the year, we want to produce a REST API so you can check what are the latest versions. You can use this REST API to find, oh, I want a link to the binary for macOS, ARM, M1, version 17. And then the REST API will point you in that direction. In January, we'll have the quarterly update, again, for 11 and 17. These are LTS releases of the Microsoft Build of OpenJDK. And hopefully by March, we will have, hopefully we do want to have this before that, but right now in our backlog, we have the Alpine Linux muzzle build of OpenJDK for early next year. And then April, we have the other quarterly update of the Microsoft Build of OpenJDK. And also these dates of quarterly updates, they also apply to Eclipse Xamarin Adoptium binaries. Well, if you do have any questions about Microsoft Build of OpenJDK, or you want to provide some feedback, or you found a bug on the installer, or something is missing that our binary does not have that other binaries do have, please provide that report to us through the Microsoft/OpenJDK project on GitHub. We are very active there, and I would appreciate any feedback, any ideas as well. We got some interesting ideas about, like, for example, I want to update Java. I want to update OpenJDK using Windows Update on my Windows environment, and that's an interesting approach. We are considering that. It's just not. It's in our backlog. So with that, thank you so much. If you want to contact me, I'm on Twitter. It's just Bruno Borges. And if you have also other questions over email, my email is bruno.borges@microsoft.com. And thank you for having me.
Hi, Bruno. Thank you so much for the opportunity to talk in our JV Montreal. My mission is always try to bring some Brazilians out that I used to watch in the Soul Java in Brazil before with Java Man and everybody, and I appreciate the attention and the opportunity. I love it. I didn't know about the jlink like that for the first time. I heard about, and for me it's really nice. I'm gonna try after to use that, and I really enjoy it.
Awesome, thank you.
I think that we don't have any questions for Bruno right now.
No questions.
Okay, and we will tie as well because we're gonna finish normally 1:30. But that's it. Thank you, Bruno. Thank everybody. We're gonna end our broadcast, and I appreciate everybody that stay with us until now. Bye.
Awesome. Thank you so much. Bye.
Bye.